Okay, I think it's enough. Welcome to this talk about reactive programming and dealing with asynchronicity. My name is Ricardo Sanz. I'm a Drupal developer and DevOps. You can find me at drupal.org as Tunic or at Twitter as Sanzante. And I'm one of the founders of MetaDrop, a medium company based in Spain. And we are specialized on Drupal development and associated technologies. First, let's see a walkthrough of this talk. We are going to talk about a little intro about reactive programming. Then we'll talk about approaches to deal with asynchronicity, and then we talk about reactive programming and its concepts, plumbing, observables, operators, then some code examples, and the final notes. The introduction, a very quick intro about reactive programming. Reactive programming is a way to deal with asynchronicity based on the observer pattern. This talk is based on the ReactiveX library, the JavaScript version. In their own words, ReactiveX is a combination of the best ideas from the observer pattern, the iterator pattern, and functional programming. The ReactiveX library can be used on many different languages, from the web server to the backend, including native application as well. JavaScript, PHP, Java, Scala, Go, Kotlin, etc. Okay, but what is an asynchronous environment? An asynchronous environment is an environment with events that happen over time that we can't predict. This is very common in the browser because it's an asynchronous environment. If we check, for example, a Drupal request, we find that the execution path is more or less predictable. It's complex, but predictable. And the data is available when needed. When a database query is done, we assume that the result, success or failure, is available in the next line of code. And it's the same for reading a file, for example. In the browser, this is not true. We don't know when many operations will return their data. Ajax operations are the main example, but it's the same for workers, user interactions, WebSockets, timers, animations. All of them are sources of asynchronicity. So how we can manage this uncertainty in this environment, this asynchronicity? Well, the first option is to use callbacks. It's a simple and classic approach. When an event is received, a function is called. This function processes the event and its data. The typical example are the listeners. Because of their simplicity, they don't allow many possibilities, only recommended for simple reactions upon events, because coding complex reaction, it's very hard, or can be very hard. The things start to get complicated when within a callback, you need more actions to process the response that require more callbacks. This usually leads to the so-called callback hell. A callback hell is a nested code in multiple levels because of the successive callbacks. This code, as you can see, it's not easy to read, it's not clean, and it's not elegant. So what was the way to solve the callbacks issues? Then the premises appear. The premises were added to ECMAScript 6, and there are objects that wrap asynchronous operations and react when there is a result, whether it's a failure or it's a success. They are chainable, and well, they greatly improve the flow, the flow and error management of this kind of operations. They were a big improvement, but they have certain limitations. They are resolved only once. They return a single value. So if you want to repeat an action, you must run again the code that you set up the promise. Usually you can do it calling again the function that manages that part of the code. But you need to control this re-execution process. This works well for one-shot actions, even complex ones, but it could be a problem when it comes to actions that are repeated over time or with slightly different behaviors. Once the promise has been fulfilled, no longer returns values. Sometimes following the execution flow may not be trivial. There are many articles explaining that you need to understand promises quite well to avoid rookie and advanced user mistakes. They are not lazy, so as the promise is created, the code that tries to solve the promise is executed as soon as possible. It is assumed that the answer is needed now. They are not cancelable, except if you are using some libraries like Bluebird. Once the promise is created, it will try to resolve or fail, but it cannot be canceled, although, of course, it can be ignored. This can result in wasted resources. And you can fall in the promise hell. That is similar to the callback hell, but to be fair, this may happen when promises are not used in the right way. And I'm not forgetting the async and await. I mean, the async and await words of the JavaScript, but at the end, it's just syntax to work with promises in a more comfortable fashion, so they have the same issues. So the promises, although they were a great improvement over callbacks, the reactive programming, I think it's even more powerful. So what is reactive programming? Reactive programming is programming with asynchronous data streams. It's the use of data pipes that process and alter the data. It's a declaration of reactions to changes. And in some way, it's similar on how Angular, React, and Vue.js update the user interface on data change. When a variable is updated, the value is automatically updated in the user interface. So it's like reaction on change. When the variable changes, there is a reaction that it's to update the user interface. What are the advantages of using the reactive programming? Well, it greatly simplifies the asynchronous work because it makes asynchronous workflows easy to describe. It's very easy to combine and manage asynchronous data sources and different asynchronous data sources. It generates a shorter, simpler, and more intuitive code. And the asterisk is here because while this sentence is true, you have to deprogram yourself a little bit from the structure object-oriented program paradigm to read the code. As a result of all of these advantages, using reactive programming means better maintainability. So now let's see how to deal with the asynchronicity using reactive programming. And reactive programming is all about plumbing. It's about creating data pipes because in reactive programming, you create pipes for the data. So you create a plumbing system that solves your needs. Asynchronous data sources are piped into our plumbing system. And this plumbing system is able to transform the data and modulate the paths the data crosses. And well, when the data reaches the end of the pipe, usually a reaction is triggered. So, okay, let's see what would be a simple pipe. A simple pipe, and this example, I'm not using reactive programming, it's just a simple callback approach, but it's good as an example. The simple example is an event that is generated in the browser, which is captured, and the appropriate action is taken in this case, showing an element of the DOM. So we have the data structure, sorry, the data source that it's a click event, and then it flows to the reaction that we want to do when it changes. This is something very simpler, that not mysterious, that we do every day. And what would be a complex pipe? This is a complex pipe. It's a pipe with transformations. The pipes with transformation are the interesting ones. For example, the transition from one click to a list of objects loaded from a service. In this case, at some point, the user clicks a button, and that clicks becomes an URL of an endpoint of a remote service. For example, let's say a competition's classification data, athletes, score, nationality, name, etc. That URL then becomes the data contained in that URL using a HTTP request. And that content probably will be a JSON. On the next step, the JSON content is turned into an instance of a custom class that contains the data received. On the final step, the final action occurs, which is to assign these objects to an internal variable. So the initial data, at just a simple click, has traveled the pipe and has been transforming the data until the final action. That's the assignment to a variable. This is nothing new. This is done all the time using callbacks or promises. We could change the output of one call to another and deal with the complexity that is produced. The good thing of the reactive programming is how easy it is to define this data management. And now we have to take a deep breath to get into the thick part of the talk. How do we create these data pipes? How we build our plumbing system? And how do we declare the reactions to changes? We'll use observables and operators mainly. The observables are the first main piece. Let's say that they are just things that can be observed, boxes where the data comes from. Basically, they are the observer part of the observer pattern. They are more than just data streams, but let's not enter into their complexity. At the moment, let's say that they are data streams. And they emit data until they finish or an error is triggered. They are like, well, just a pipe that they emit values until they finish. The operators are the second fundamental part. They are used to chain observables because they read from an observable and they output data as an observable. They allow data to be transformed in more or less complex ways, but it also allows flows to be modulated. For example, preventing data from passing if it does not meet certain conditions. They also serve to create observables, for example, to create an observable from an event of the DOM. So when that event occurs, the observable emits the event. Let's see a couple of examples. This is the filter operator. What it does is to filter values according to a certain condition. First, I have to explain this diagram. As you see here, I have two observables. The first one on the top of the image, and the second one on the bottom. And in the middle, I have the operator. This is a way to describe how an operator evolves during time. The first one, it just, sorry, the operator, no, how an observable evolves during time. In this case, the first operator emits first one numeric value, 3, then 6, then 5, then a little delay, and then 12 and 2. Then we have the filter operator that, as you can see, it filters the values that are not even. So on the first observable emits 3, 6, 5, for example, but the second operator, the second observable will receive, well, and emit only the 6 and filtering out the number 3 and the number 5. Another example is it's the map operator that it simply transforms the data. In this case, what it does is just multiplying the received value by 10. So we have first 1, and the operator, the output is it's a 10. Then the first observable emits 9, and the operator will emit 90. So as you see, it's very simple. Operators just take data from an observable and emit the altered data. Now let's see some code examples. We are going back to the previous example, the request URL and instantiate the data. So we have a mouse click that becomes an URL, that becomes a URL content, that becomes instantiate objects, and then we assign it to a variable. So what we do, we create an observable from clicks from a button. Then we start to create our pipe. What we do is to map each value to a string, that the string is the URL we have to query. We don't care about the exact data of the click, but each click is converted into a string. Then using this operator, we query the URL, we wait for the result, and the result is piped to the next operator. In this case, it's just a map operator that it takes each item on the JSON and create a new instance for each element. And finally, we just subscribe to the pipe. This is like adding the endpoint of the pipe. And we just assign that list of instance to our internal variable. So that's all. This is the pipe we have created, and our reaction to a change, and the change is the click of the user. This is okay, but let's say that we want our page to auto-refresh the results without without needing to click the button. What we will do, it's more or less the same. We create an observable with the clicks of the user. Then we create a new pipe that it starts with a true value. It's simply it's an observable that inserts a true value in the pipe we create. Then in that pipe, we use this code, but this code, what it does is when it detects the click of a user, it inserts a new value after 60 seconds. And you may say, and why is that? This is because the auto refresh, we don't want to auto refresh just after the user clicked the button. So what we want is that the auto refresh only triggers 60 seconds later after the user clicked the button. Okay, so that's the way we modulate the auto refresh ticks. Then we merge that auto refresh clicks that come 60 seconds after the last, every 60 seconds after the last user click with the user click, because we want the user to be able to refresh the page. And then we add the code that we used before. If we see this as a diagram, you can see, okay, this is the previous diagram. Now we have added this part. This is, as you see, we have the mouse clicked. And so when the user clicks the mouse, it goes this way, all the way here until we do the assignment to the variable. And at the same time, when the user clicks the mouse, it goes through this pipe. It merges with this observable that it's the first observable that triggers the first auto refresh, and there we have the timer. So when the user clicks the mouse, it goes this way, and then the timer starts waiting 60 seconds, and triggering a value that goes that way and starts again the refreshing the page. Let's say that some users don't like the auto refresh and they want to optionally disable the auto refresh. How we can do it? Well, we use the first code on the first part, and then we add a new operator that filters the pipe that includes the refresh pipe. So when the auto refresh variable is off, no data is crossing that part of the pipe, and then we use the same code as before. We can see this diagram. This is the previous one, and then what we have added is just, instead of the timer going directly to this box, we have added operator that filters this branch of the pipe. Okay, so as you see, making it optional is just adding this line of code. Let's say that the user are clicking too often the refresh button, so we want to prevent from nervous users and do not allow them to refresh the page until 15 seconds have passed. How we can do it? Well, it's very simple. We take the click stream or the pipe that handles the click, and we add a new operator that throttles the data. What it does is don't allow new values until 15 seconds have passed, and then the rest of the code that defines the pipe. We see a diagram. Remember, this was the previous one. This is this pipe with the throttled data on the mouse click pipe. As you see, we have just added this throttled box. And what about error management? No problem. What we do is adding the same code that creates the previous pipe, and then we add the catch sentence. And what it does is, if there is any error inside the pipe, it just takes the current list of items and pipe in. So when we get to the end, the final action, that it's assigning the received list on the pipe to the internal variable, there is no change because we are using the same value we have before. In a diagram, we will say that we have added this conditional pipe, let's say pipe, at the end of the pipe. So if there is any error, because the error they are propagated through the pipe and they are catched here. So I think this shows the power of the reactive programming, in the sense that you can write complex behaviors with little code. As final notes, why you may use reactive programming? Well, because you can express from simple reactions to extremely complex reactions to change. Callbacks, for example, they only express simple reactions. No more halts. Reactive programming is not about nesting code, so you are not going to face that problem. Observables resolves as many times as needed, so they emit values, not just one. The execution flow, it's more intuitive. You have just to read the pipe. For complex pipe, it's true that it's not so obvious, but I bet it will be worse using other approaches. And of course, you have to be used to operators and the different options you have when using the reactive programming. The operators, the observables are lazy, but they can be not lazy as well. Reactive programming is cancelable, so you save your resources. And well, when is good to use reactive programming? Well, when you have many asynchronous data sources, because reactive programming is easier with reactive programming is easier to manage many data sources. So in a high asynchronous environment, you should think on this. When you have complex interactions, because it's easy to program complex interactions with reactive programming using our plumbing system, or when you have complex interdependency for the same reasons. And to avoid internal state, to manage asynchronous events, because the reactive programming and especially the operators, they deal with that internal state if needed. So you don't have to use it. A few notes for about the observables. They can be asynchronous or synchronous, because the, observables are very flexible. They have many possibilities. They can be cold or hot, and this is a big topic that I prefer not to enter now, because maybe we don't have enough time to explain all the concepts of the reactive programming. They can be multicast or unicast. So you can subscribe many. You have many subscribers. You can have many subscribers to a pipe or an observable, and they can share or not the data source with their subscribers. This is interesting because it's like you can have an observable that emits values with the same behavior with two different subscribers. In not exactly different, but they behave the same, but they don't have to share the data. We have only scratched the surface of the reactive programming, because there are other components that are interesting when using reactive programming, like the schedulers, for example, or the subjects, but they are, well, this is out of the scope of this talk. But I think that you have an idea of why it's interesting to use reactive programming. Why to adopt? Well, because others have already done it. There are several companies that are using it internally, because it can express very complex models, because it can handle any data source. I think that almost anything can be wrapped in an observable. The observables have been proposed for standard in JavaScript. Currently in stage 1, it's a little bit paused, but they may make it in the future. At the end, you will write less code. What it means improve maintainability. It's available in many languages. It's not something that it's only linked to JavaScript. So you will learn reactive programming you can use in many other languages. And well, why to adopt? If I mean, asynchronicity. If you deal with asynchronicity in complex way, you probably benefit of using reactive programming. And as a final example, I want to share my personal experience. What you see in the screen is this is the mobile app for the World Archery Federation, one of our clients. You can see that there are 3 drop-downs, and each one is dependent of the previous. If you change, the next drop-down change. The data is not just retrieved from an endpoint. We need some previous data to render drop-downs. We need identifiers, we need labels, etc. So we have a lot of dependent data. You may argue that the API should be simpler to use, and I will agree, but it wasn't the case, and we had to stick to the already existing API. The data is refreshed, sometimes very often. While the view you are seeing, it's pretty static, the underlying library that accesses the API is prepared to refresh data automatically and on demand. This will affect the displayed data, the widgets, etc. The app should work offline. So the library builds a local data repository with the fetched data, requesting fresh data when it's outdated. As a result, this was a pretty asynchronous hell. We worked on this with Angular JS without reactive programming, and those days we lost some mental health. And then we did it again with Angular and reactive programming. And although it was hard because we had to learn how to use it, the asynchronous hell just became a complex but funny problem to solve. And you can get application from the Google Play Store or the iOS Store. To finish, I would like to post here some links. One is an introduction to reactive programming that it's very, very interesting. It's probably the starting point. You should check it. Then interactive marble diagrams. The marble diagrams are the diagrams with the balls for the observables. You can see because sometimes it's hard to understand how operators works. These interactive marble diagrams allow you to understand quite well how they work. There is an RX visualizer that allows you to create some observable interactions and see how they work. And of course, the ReactiveX homepage. And that's all. That's all. Any questions? Let's see. Does this require a specific JS library to be added to a project to use reactive programming? Yes, you need this talk is based on the ReactiveX library. Well, I have linked it and I have shown in the links. And as I said before, it's available in many languages, not only in JavaScript. But if you want to use in JavaScript, you have to add it to your source code. What resources did you find most useful in learning reactive programming? That's a good question because the reactive programming, it's true that when you approach to it, it's hard to understand because because it's very different to what we have used usually. I recommend clearly this introduction. Okay, it's a bit long, but it's very, very interesting. Of course, then you have to understand the different operators and observables. So those interactive marble diagrams and the RX visualizer is very interesting, and especially you have to to test it. But this introduction, I repeat, it's something you have to read. Does it make sense to use this approach in React apps? Well, I guess yes. I'm not very used to React, but at the end, React, let's say that React has a hard-coded reactive programming inside because, well, it reacts to changes. But at the end, there are more changes that you may add, more reactions to changes that you may add to your application. So I think it makes sense to use reactive programming using React. Can we use reactive with Drupal? I don't know if you mean on the front end, on the back end. On the front end, obviously, yes, because at the end it's just JavaScript code. In the back end, I mean, theoretically, you can use it because there is a library, a version of the library for PHP. So you can use it, but I'm not sure if it's worth, because at the end Drupal is it's not asynchronous, as I said before at the beginning on this talk. When Drupal is running, the code path is more or less predictable, and there are no asynchronous operation, or the ones that there are totally hidden. I think that, for example, Gazelle uses some asynchronous capacities of PHP, but when you use Gazelle from Drupal, you call that Gazelle function or whatever, and you have the result immediately after. So I think that until Drupal is still, let's say, a monolithic synchronous, well, not monolithic, but synchronous application, it's not very useful. If we convert Drupal to a always running application using something like React PHP or something like that, it may be interesting. Are there any test frameworks for reactive programming? Testing asynchronous code can be very complex. Good question. And I must admit that I don't know the answer, but the thing is that because you are using reactive, if you are using reactive programming in the front end and using JavaScript, you can test the application using frameworks like, well, in our case, we use a lot of Behat that tests then Drupal and the front end, but you can use any other BDD testing framework that tests the JavaScript. And at the end, you are just testing the complete application. So you don't care if it's using reactive programming or not. So at the end, you are checking that the application is behaving properly as a complete package. I understand that it's also possible to use unit testing or similar testing using reactive programming, because at the end it's just JavaScript code that you can execute. So I guess is well, you can integrate in your testing workflow without suffering a lot. Okay, I think that's all. No more question. Let me see. Okay. We have 5 minutes. I don't know if I may show you some more examples, or do you have any other question? Let me check if I have some code available. No, I was going to show you some other examples, but I don't have at hand. Sorry. Well, to finish the talk, well, the questions that we have already done. Remember that there is a contribution day on Friday, so everyone is welcome to contribute this Friday, and you can say what you think about this talk, and I think that's all. Thank you very much to be here, and I hope you have enjoyed the talk.